We're about to do.
All right, it's time for us to get started. Nice to meet those of you I don't know. I do see the occasional familiar face, but for those of you who don't know me, I am Dr. Chris Kane. I really don't care what you call me. I'm not one too much for formalities. I would rather have you call me something that is comfortable for you, something that helps you to want to engage with me or interact with me rather than force arbitrary titles or names. So if you'd like to call me Chris, absolutely fine. So that I don't waste too much of the TA's time, maybe have the TA come up and introduce, one of the two TAs come up and introduce himself. And that way I can get him out of here.
Appreciate it. Hi everyone, I'm Akiva. I'm one of the two TAs for this course. Not super common to need two of them, but here we are with 46 students. In case anyone here hasn't worked with a class with a TA before, all the TAs have taken the course that they are TAing for. We assist the professor with grading and with assignment structures, and we are also available for office hours so that we can help take some of the office hour load off of the professor. I have office hours Monday, Tuesday, and Wednesdays from 10 to noon. And you're also free to email me, ping me on Discord, ping me on Canvas, anything, and I can set up appointments or meet outside of my office hours. So any questions you have, you're free to direct them to me. If I don't know the answer, then I'll kick it over to them. So, my office is one of the cubicles. It's 345A. It's the first one on the left as you're walking past them. And I'm usually in my cube. So we're also free to just book your head in. Have a good quarter, and I'll see you all around.
Within about 5 steps of my office. So if you can find one of us, you can find the other as well. Very much. Awesome. Thank you, Akiva. The other TA is Rob Locke. I haven't had a chance to connect with him quite yet with regards to what his contributions might look like. He's not usually around quite as much, so I don't anticipate him having as many office hours or being around quite as much as Akiva is, but he's excellent. I've had him as a TA in prior classes. He cares a lot. He's a great person to go ask questions. That said, there is certainly overlap between his office hours and mine. Not something that we try to do, but it's the times that work out for us. So my office hours are Monday, Tuesday, Wednesday, Friday from 10 to noon. We're only technically required to have 1 hour, 2 hours of office hours a week. I do not abide by that because a lot of learning happens in office hours, and it happens to be my absolute favorite kind of interaction that I have in this job. So I try to maximize as many office hours as I can. And then if the office hours don't work for people, I try to find times that do work so that you can get what you need out of the class. It is very, very important to me that that be the case. So things to know about this class. It is going to be extremely challenging, as is just about every class that I teach, but I don't do that without having the ability to support you through that challenge. So I will meet you halfway with regards to the class requirements. Through everything that I assign, I will be there to support you through it. Be that during these office hours or at a more convenient time for you. We will figure it out as long as you're able to advocate for yourself, request what you need, and we'll find a way to make it happen. All right, let's go through this document. It's my favorite first day game. Find the typos. Find the things I didn't think about. Most of these things you can read on your own. First thing that I see here that's necessary, obviously you are in the right time, the right room at the right time. But there is a textbook, Introduction to Algorithms. I don't like requiring textbooks of people. That said, this is one textbook that I used the 3rd edition of when I was an undergraduate, and it is one of the few books that I think every computer scientist should have physically on their shelf, if not digitally and accessible. It's one of the good textbooks that are out there. So it is a long-term investment to have a copy of. I do plan to assign some reading out of it assign some problems out of it, so it will be useful to have. Where whenever I can, I will share screenshots of problems, etc., on Canvas to make it as easy and simple to interface with that as possible. My policies about responses: if anything comes up and you can't attend office hours, please email me. I guarantee responses within 24 weekday hours, and because I tend to get spammed with emails, it's very important to recognize that occasionally one slips through the cracks. And so the reason that I guarantee responses in 24 weekday hours is that you know when that happened. I am not trying to ignore you. I am not trying to fail to respond to you. If 24 weekday hours elapse, something happened. So that means you should follow up. Just send me, it doesn't even have to be a new message. Just respond with ping or something of the sort, like, hey, please respond to this email, and I will prioritize that at that point, especially if it's been 24 weekday hours. But that does mean that if you have absolute last minute homework questions, I can't guarantee that I get to them on the night that it is due. I will do what I can, so please still send the email. Don't anticipate that it's going to be 24 weekday hours. I tend to be much faster than that. But I do what I can, and that is that. If weather doesn't agree with us, which this year it doesn't really look like that's ever going to be a problem, the default expectation should be that we are going to have class synchronously on Zoom. So links to that are in the module section of Canvas. I can bring up Canvas and show you exactly where that is, but this class is being live streamed, and each class will be posted to my YouTube channel so that if you are unable to attend, it's not a huge deal. I don't want this to become an expectation that people can attend remotely consistently. I think there is a lot to be gained from in-class attendance, especially in a class like this that is difficult, that will involve lots of practice problems and going over material in class. I have historically heard that you miss one day of my class, you walk in and it's like you're in a completely different class that you didn't sign up for and you don't know what's happening. So I highly recommend, even if you miss a single day, try to watch a lecture videos. If you can, attend remotely. If you can't do that, watch a lecture video before the next day, since I tend to upload them in when I get a moment, and those can be fleeting. If there is a lecture video that you would like to refer to that is not up yet, please, again, send me an email. And knowing that someone is immediately wanting to watch that, I will prioritize it and get it up as soon as I can. But if you can't attend either of those, then come see me before the next day of class if possible. And make sure that we stay caught up, because this class will move very fast paced. There's a lot to cover in 10 weeks. This is one of the most important classes in undergrad computer science from my perspective. So it's one that I, as a professor, take very seriously with regards to the content that is covered, the pace at which it is covered, to make sure that you have the background that you need with regards to this material. I don't want to send you off into the workplace without the skills that you're going to need to be successful. I mentioned that office hours are my favorite interactions. It allows me to get to know you as a student, get to know what you want to do for your career after you graduate, what courses you've taken, what courses you are taking, how you learn, so that I can structure how I engage with you in a way that maximizes the chance that it is successful. If you are a visual learner, I learn that and then make visual examples. If you are a logical learner, I break things down logically. I try to meet you where you are, where you learn, so that you get the most out of the interaction. But that's hard to do if people don't show up or ask for it. Other things we can read for the most part: grading policy for the class. This is different from most classes because I have a very different, I'm attempting to modernize my approach. So 80% of your grade is homework and projects. That is a significant portion of your grade. Exams don't carry a ton of actual grade weight in this class, because where most of your time and energy and attention is going to be spent is on homework and projects. So I want your grade to come from those homework and projects. I take that seriously. Only 20% of your grade is going to be determined by, I say approximately 4 exams because there might be 3 of them. This is my first time teaching this class here. So because of that, I don't have 100% of the plan figured out for what's going to go well, what's not going to go well. So I leave myself a little bit of wiggle room where I need to. If there's nothing to put on a final, I am not going to give you a final. We will see how that goes. There is, however, one very big contingency on that 20% exam score, and that is that everyone in here will need to average a 70% on exams in order to get a C plus in the class, which is what you need to be able to use it as a prerequisite. So exams, in addition to being 20% of your grade, are more of a pass-fail type of assignment, type of engagement. And the reason I do this is I absolutely hate looking at assignments for plagiarism and AI use. I think it's a complete waste of everybody's time. But the way I can build that into the class is that in order to be successful on the exams, and I write challenging exams, is to understand the assignments at an intuitive level. So the TAs will still be looking for things like this, and we'll talk about the AI policy in a second. But I loathe it. I just think it's a complete waste of time. So the way that I go about making sure that it minimizes its effect on the class is by making it worth your time to engage with the assignments at that level. If the class says prioritize these outcomes, then people more frequently prioritize those outcomes. In math classes that are 0 to 10% assignments and a significant portion exams, people don't put as much effort and attention into the assignments because there is little grade weight associated with that. So I try to put the grade where the emphasis should be, which is where I can actually have you take the time to implement things, to think critically, to build solutions to problems. Questions so far? I use a semester-based grading system, so it's not quite the same quarter-based grading system you might have seen in other classes. However, I do very frequently, in fact, in just about every class I ever teach, curve at the end of my classes. So the grade that you see on Canvas is guaranteed to be a grade floor. The grade that you receive at the end of a quarter will be greater than or equal to the numerical grade that is on Canvas, but it is not guaranteed to be that grade on Canvas. One other way that I use office hours is I get a sense of, on a student-by-student basis, as I get to know you, would the grade that I assign you at the end of the quarter map to the effort and understanding that I saw throughout the quarter? To design a system like this on the very first day of class, I have to have a perfect understanding of how your learning is going to map to a number. And I think that is folly to assume that I can perfectly do that with a system and be happy with every result. So to the extent to which I know and understand your learning, what you put into this class, by the end of the class, I will go student by student and determine how happy am I with the grade that Canvas tells me that I should assign to you. How happy am I with that? If I am unhappy with that more than a couple of times, I'll curve up the whole class and then ask myself that question again. And then I will continue to do that until I feel like I've reached a natural cutoff point where those who have put in the effort, the time, have the understanding that I feel like is a passing level of understanding. Those students are through, and the students who I feel like could benefit from some repetition from this content, they will need to take the course again.
Okay.
So it is a grade floor. There is no way that I ever curve down. I will never disagree with the math to the point where the grade you receive is lower than that, but it may very well be higher. And that's okay, because I use it as a way to challenge people. I don't get scared of grading curves too much. If I give back an exam and the average is a 60, I will give that exam back with an average of a 60 so that we can talk about what happened. I take half the responsibility for that, for sure. but I want to be realistic with regards to grades and the level of understanding that exists so that we know where we stand. But it won't necessarily be permanent. And I will be very upfront with how I feel about grades and grading throughout the quarter. It's not something that I want to hide or have it be a surprise at the end of the quarter. For exams, more and more people are doing this. I think I might have started it here, but you can bring a sheet of notes with you front and back to exams. Other than that, they're closed note, closed book, etc. But you can bring a sheet of notes with whatever you want on it. I will not collect that sheet of notes. You're welcome to collaborate when you design that sheet of notes. I design exams to make that sheet of notes as useless as possible, or as background as possible. So I'm not going to write exam questions that have you regurgitating material that you have memorized. That is useless. You can look it up on the internet within 2 minutes at any point. Why would you have memorized it in the first place just so you can forget it 5 minutes later? I will be asking you to apply tools that you have seen in class to problems that you have not seen before. And if you understand how something works in the big picture, then you'll be able to do that. So that's where the focus will be. In general, I have a 1-week turnaround for grading. In a 46 student class, I will ask for as much leeway as I possibly can with regards to turnaround. It's not completely in my hands, depending on graders, but I do prioritize it. I will put pressure on graders to make sure that you get timely feedback for things. But it is a challenge to do in a class as large as this one. I try to make consistent weekly due dates so that you don't have a lot to remember with regards to the class. So assignments and projects will always be due Wednesday evenings unless something happens and I have to change that or push it back. But the default will be Wednesdays and exams will always be on Fridays. I reserve the right to change that as needed, but I will do my best to stay consistent with regards to due dates. Make that as easy as possible. Our policies. I think the most important thing to hone in on here is the AI policy for the class. And I wrote this myself yesterday. I am not an AI hater by any means. There is absolutely a place for AI in computer science. It's just that this class is about building fundamentals. And AI can be used in one of two ways. It can either be used to augment your understanding and to save you time. If you could already implement something, then using AI can save you time. If you could not do this on your own, then what you're doing is you're circumventing the learning outcomes of the class by trying to have something else do your work for you. And that's right where I draw the line. If it is a time-saving metric, that's awesome. If it is a circumvention tool that allows you to submit something that you otherwise couldn't, that is an academic integrity violation. So for this class, because we are building those fundamental tools, I really don't want to see it. I have other classes where I have no AI policy. You take my AI fundamentals course and all limitations are off. I actively design things around your using AI to meet the outcomes. So things to look forward to once you take higher level classes from me. As we're building this, on the other hand, I feel like for the most part, AI use is more on the lines of circumvention than on augmentation. So because of that, again, I really just don't want to see it. And I do my best to build that into the class where you're going to get more out of not using it than you would out of using it. I will support you through. If you're struggling by any means, come see me. I will gladly take the time to figure out what's happening, to help you where you are, help you be successful, learn the material. So much easier. You'll get so much more out of it than trying to take a shortcut. I don't say that to be scary. I say that to beg you to come utilize the resources that are available. I do everything in my power to not be a judgmental entity. I will meet you where you are, regardless of your background in computer science, regardless of what you're currently working on. Office hours is not a place just for people who are struggling. If by going to office hours, you're not admitting anything. It's a nice workplace. I don't tackle students one at a time. I try to invite as many people who have similar questions into the office at the same time. We'll have 6, 8 students in there at a time, all working together to understand things from each other and from me. So it's really a place for class part 2 to help meet you where you are and get you through the class. Any questions so far? I think that's just about everything that is here in this document itself. We've gone over accessibility for the class, outside of class. What else do I want you to know about this class? Question?
Homework is gonna be due on Wednesdays. When will it be assigned?
If it's any kind of large scale project, it will be at least a week in advance to give people enough time. I'll try to assign something by Wednesday that is due the following Wednesday. And that's just because the nature of a lot of the assignments and projects in this class will take quite some time. It will be the procrastinator's nightmare to be in here. I assign things with enough time to complete them. So if you're starting the night before it is due, it is going to be very scary to try to get that all done in a single setting or within 24 hours. So take the amount of time that an assignment is given as some kind of measure of how long it will take you to implement it. Yeah.
So what are like some patterns or themes you see in like successful students in this class?
That's a great question. Well, I haven't taught this class specifically. It is very similarly designed to a lot of my other classes where I have seen what success looks like. I think self-advocacy is the best thing you can do for yourself. Is if you start to feel like, I don't really understand that well. Way before the panic moments where you realize, I don't know if I can recover from this. As soon as you have a question, get an answer to that question. If that means raising your hand in class and asking it, great. I love questions in class. I pace my class with a lot of interaction where I can. I don't want to just be talking at you. I want to be giving you problems. I want to have you working in groups. I want to have examples that we will go over. So ask questions. If you still have a question at the end of that, come see me in office hours. I would love to talk to you about that question. Get that question answered. I absolutely love to see it. And if you do see yourself starting to struggle, you don't have to come to me with a solution to that. Just the admission of, I don't know if I'm doing well at this right now. There's something wrong and I don't know what it is. That admission by itself starts a conversation. And the end result of that conversation is usually a plan of action. Something where I can continue to check up on you, ask you questions, prodding questions of what do you understand, what do you not understand, with the sole purpose of helping you with what you don't understand to get it to the point of where you understand. So engagement in the class, attendance, self-advocacy, asking questions, getting help. Even before you know you need it, just the fact that I think I might need some help in the near future. Good enough to get started. Yeah, I want to make sure that I set an atmosphere that is conducive to learning, conducive to that self-advocacy. I take your place in this class very seriously. Everyone belongs here regardless of where you're coming from, how well you've understood past material, what level of experience you have. I don't care. I just want you to be successful. I'll do what I can to help you do that.
Wonder if you could give us any type of like a preview of what the projects in class are going to
Yeah.
look like?
So algorithms can be broken down into 2 large scale categories. I think you have monumental algorithms in computer science history that are used all the time out in industry for you to know and understand. And then there are algorithmic properties. There is how to use the tools that you have to solve a problem that you haven't seen before. So we'll be talking about those kinds of tools. What tools can you use to solve a problem that you haven't seen before? So projects will target one of those. It will either be implement something that is historically very significant and used in modern programming all the time, or here is a tool, here is a project built around your getting experience with that tool. Implement something that utilizes it. So a lot of it will be programming heavy, and some of it will be kind of a theoretical assignment. But for the most part, expect something on a weekly basis. There will be a project that you're working on just about every week, because there's a lot to this class. It deserves a semester. We have a quarter. Other questions or concerns? I very much want to address anything that is unclear at this point. Have a schedule. This we can go over. So the fourth exam is kind of off the end here on the finals week that's not here, but this is a best guess at the pacing that we will be covering. I will have study guides at least a week in advance for all exams. So the Friday before, the Friday that is the exam, I will give you a study guide. The way that I make those study guides is I go through all of the material that we've covered and I write down a list of important topics. And whenever I can, I phrase them like a question or phrase them like a statement that you should be able to do. Know how to this. Be able to this. Something like that. I find it very useful in my classes, or I've heard feedback that this is useful, to go element by element in the study guide and make your sheet of notes just by filling out everything that you know and can refer back to any material from class about those topics. Because how I design exams is I go back to my own study guide and I get inspired by the questions that are there and try to write questions that are related to the questions that are on the study guide. I very rarely copy them word for word, but I might design a problem around a be able to do this. Now I will implement an example of that question with some work around it. So some story, something, have you do that, but again, with a problem you haven't seen before. So it shouldn't be, I don't frequently get the feedback that exams were out of left field or the questions, you wouldn't have seen them coming, but they're not going to be easy fodder that you can memorize or just look at your sheet and have the answer for the most part. It'll rely on your knowledge of the material, your intuitive understanding based on the work that you've done on the projects. I want to tie the class together so that everything is useful, everything is relevant. I am not wasting your time. Your time here is important to be focused on doing things that will be useful to you. If we want to summarize what I'm here for, I want to maximize the cumulative amount of learning that happens in this classroom this quarter. And in order to do that, I do my best to support you. I do my best to challenge you so that you have to put your best into it. And as we are pushed a little bit beyond our comfort level, we grow. We learn new things. Any other questions? I think we can start diving into some content then. If you think of a question as I'm getting that set up, feel free to raise your hand. We'll get that answered. Excellent. Have no internet. that what I'm getting at this? Believe in you. I no longer believe in you. Trying to open old things that have moved, that's the problem. Okay, so I will probably be spending a lot of time in the class asking people questions about your data structures experience, about what was covered, the extent to which you have an intuitive understanding of that material. There are optional points in this class where I will be potentially going back to some data structures content or just covering what I have historically covered in data structures if there is significant enough demand. And I get that sense of we could use that refresher and push a little bit beyond that. So a lot of that will happen early. And a lot of that I've already assumed would be useful. So hold on for that. I like to motivate everything that I discuss because nothing is more frustrating than having someone talk to you about something that you don't understand the value of or how it's going to be useful or used. So start the class with why even study this? So we'll start with just a basic definition of an algorithm as a well-defined computational procedure, taking in one or more values as input, really zero or more values as input, producing zero or more values as output in a finite amount of time. So basically, all we have here is the ability to solve a well-specified computational problem. Examples that we've seen in prior classes, what's an example of an algorithm that you've studied or seen or implemented? Merge sort?
Yeah, we
That
went.
one?
Yeah, we went through a lot of things. We're most like. Yeah, so we went through a lot of like look, yeah, doing recursion.
Recursion is a tool, not an algorithm. I think that's a
Oh,
good,
yeah,
that's a good example.
Yeah, we did do a ton of different sort practicing, including
Yeah.
fusion sorts, and yeah, we went through a lot of things. So
Yeah.
With algorithm,
Dijkstra's?
yeah,
Where did we see Dijkstra's before?
in networks.
Yep, good. We'll be covering that again
Oh,
because we
I
need to, but
I remember going through Dijkstra's algorithm.
we will cover more. Yeah,
Binary sort.
binary sort.
Oh yeah.
So let's grab onto one of these as an example, just thinking of, again, how this is transforming inputs to outputs. How does merge sort work as an example of converting inputs to outputs? What's the input to merge sort?
An unsorted list of values.
Yeah, some list or array of values. Great. What is the output to merge sort?
That list of unsorted outputs is turned into a sorted list of outputs.
Yeah, via some sequence of steps, we're converting what was fed in as input into what we are assuming is the correct final output. So it is the sequence of steps or the procedure of converting the inputs into the outputs. Next question I might have for you, you took a class called data structures. What is the difference between a data structure and an algorithm?
The data structure is more like the tool that you use to accomplish the algorithm.
Okay, the tool you use to accomplish it. Interesting, I like that. Other thoughts?
Following up with what he said, I feel like a data structure is more of a compositional object, like stuff with references. Like for example, I forget the term, it's been like almost a year. Like for nodes, like referring back, going forward. Whereas an algorithm is actually the procedure in which you actually interact with those data structures.
A data structure is a storage structure. It's where we are keeping track of information. An algorithm is a step-by-step defined process. So it's frequently these two classes are taught in a single class in a semester-based system rather than divided in a quarter-based system. You probably spent some time in data structures thinking about and covering algorithms. And in algorithms, we will spend a little bit less time talking about data structures, but it's a point that is frequently confused. So we want to make this precise, I suppose, make language describing this precise. So an algorithm does not rely on the underlying data structure. An algorithm is a sequence of steps that might make some assumptions about how the data is presented, but not necessarily how it is internally stored. So when we say merge sort, can we merge sort an array list in Java? We absolutely can.
Yeah.
Can we merge sort a linked list? A singly
Yes.
linked list, a doubly linked list,
Yes.
a linked list with a dummy head or a non-dummy head? It doesn't matter what the underlying representation is, the algorithm is separate from the underlying storage. So the sequence of steps of what you do when we're referring to the next stored element, we're not trying to figure out how do you access that next stored element. That is dependent on the underlying data structure. If it's a linked list, you'll query the current nodes.next. If it is an array or an array list, you're going to immediately access its index, which is going to be the current index plus 1. There are different ways to do this, but when we're talking about algorithms, we want to make sure that that is abstracted and we're not making assumptions about the underlying storage. So try to find ways to think about a programmatic concept in those two components, the structure that we're using to store the data and the process by which we are analyzing step by step how to transform the input into the output. Those are separate questions. Okay, next question I might have for people. How could we define if an algorithm is correct? An algorithm, I could just tell you an algorithm. I could say this sequence of steps transforms a potentially unsorted list of values into a sorted list of values. What processes could we use to determine if the sequence of steps that I tell you actually sorts the list? Yeah.
The output.
Sure. That's kind of the concept of a unit test. You would have some already created list of values, and you want to determine via the sequence of steps if that unsorted list becomes sorted at the end of it. Is that a guarantee of correctness? If I give a list of integers 6, 5, 4, 3, 2, 1, and it sorts it into 1, 2, 3, 4, 5, 6. We guarantee that it will work for every other list as well.
No.
Not necessarily. So there's a big process for this in testing. You'll go through that a lot in 350 in software engineering, in later classes as well, to figure out what kinds of tests should you write for this. But it is a long, complicated process to determine that an algorithm is correct. In the largest scale picture, you can use math proof. You can go through an actual discrete process that proves that for any possible input, we can guarantee certain properties about the output. That is usually a long, complicated process. But the way to define this succinctly, for every possible problem instance, there are probably infinite. It halts and outputs the correct solution to the problem instance. Is the algorithm correct if I pass it in a particular list and it goes forever, or it spins in some kind of infinite loop?
No, because algorithms are meant to be finite, not infinite.
They need to stop. Yeah, we need to get to that answer. We can't just continue to do work forever. Algorithms don't need to be specified in code. You can absolutely specify them in code, but you can also specify algorithms in English as a set of written instructions, hardware design in terms of logical gates, language agnostic pseudocode. This is just sequences of what sounds kind of like a programming language, but isn't necessarily adhering to any specific programming language. But you could easily convert this into the programming language of your choice, as long as you can read the pseudocode. So algorithms are specified in a number of different ways, but we have to make sure that the specification is precise and unambiguous. I could not give pseudocode and have two different people in this class interpret it differently, and both of those interpretations be valid based on the language that I give you of those steps. An algorithm must be unambiguous, must be precise. There's no guarantee that there's just one implementation. There are likely infinite implementations of a particular algorithm, especially within the confines of a particular programming language. If we go back to our example of merge sort, how many different ways are there to implement merge sort just in Java? I will argue there are infinite ways to do so. There are an infinite number of different character strings that would all be classified as merge sort. They might not all share the same computational complexity, so not necessarily the same runtime. They might not even have exactly the same ideas, or in the same order, or with the same breakdown, the same methods. But they would all transform the same inputs into the same outputs. So the reason to study this is the language of computer science. If you're going to go out in the world and solve problems, then we need an ability, a language to be able to talk to each other about how to be on the same page as we go solve that. Even more of that will come for those of you who haven't taken software engineering yet, in software engineering, where you learn how to work together and solve those kinds of problems. But we at least need a standard language to talk about them. Any questions from any of this? Onwards then. So since there are an infinite number of algorithms and an infinite number of implementations of particular algorithms, we can't just iterate them. I can't have you memorize them. Memorizing is usually a waste of time anyway. But there are many abstract techniques that are worth knowing, because that is how you're going to be solving those problems. You're going to be utilizing those tools and implementing instances of those tools as you solve problems that you haven't seen before. If I had to summarize this class in one sentence, it would probably be basically exactly that. How to solve problems you haven't seen before by using tools that you learned in this class. So the techniques that we will cover are like tools in a tool belt. If you recognize a problem in front of you, then there is an appropriate tool that will help you manipulate the problem into something that is a solution. You will utilize the tool to solve the problem. If there is a piece of wood that is unattached from where it needs to go, you can use the tool that are hammers and nails in order to put those pieces together. Algorithmically, very similar. So we will be introducing and getting you experience with all sorts of algorithmic techniques. We've seen a couple of them before. So as mentioned before, recursion is an example of an algorithmic technique. That is the technique of divide and conquer. We'll cover that in a little bit more detail in a bit. But I've been using merge sort. Who's seen merge sort before in some class or another? I think that's just about everybody. That is excellent. I'm using insertion sort as an example here because I was not absolutely sure that people had seen more advanced sorts. So we're going to go back to one of the sorts that you learn about and then never use again. So who remembers insertion sort?
I do.
Yeah, insertion sort. Garbage complexity. Who wants to explain insertion sort at a high level? What is insertion sort doing? How is it sorting a list?
Well,
If I remember correctly, it takes a list and then it basically splits it up in parts where there's like a sorted area, and it takes out a piece of the unsorted area and sorts it into the sorted area.
Yep.
And then it just does that until there's nothing left.
Yep, that is exactly right. So,
That's in a nutshell, a decent amount of times those sorted areas, those sorted areas are basically sorted by, solely by the lowest number you can find. Throughout that whole list and then sorted in. To put it into order, I don't need a.
for a list of size 1, is it sorted?
Yes,
Guaranteed to be. So we start making that assumption. Regardless of how large this list is or how long this list is, the first element taken as a list by itself is sorted. To sort a list of 2 elements, if we assume that the first element is sorted, the second element is either larger than or smaller than that first element. If it's larger than the second element, it's already sorted. But if it's smaller than, we need to take it out, move over the first component to create space for it. But actually, I should do work where? Classroom, new place for work. We're going to store this off in some temporary memory. Let's say this was 7 and this was 4. We'll store off the 4 in a piece of memory. We will first determine, is the 4 less than the 7? If it is greater than, it's already sorted, but since it's not, we will store off the 4, overwrite the 4 with the 7, and once we reach a place where the prior number is less than, then we just write this number in place. And you continue that process. For each new element, you just backtrack, continue to move everything over, making place for where eventually it gets inserted, which is where the name insertion sort comes from. So you're creating space for that insertion. Move over the larger things, always making room for an extra element. When you find the place where that element goes, insert that element. And if you repeat that logic for every element in the array, the list, you end up with a sorted list. We'll eventually know where all of the erasers are in this class. Always a hunt. This has no back. What is it being doing here? The back is first day problems.
of course. We do not care for those two.
We just buy very cheap ones. They break the locks. All right, so that's how insertion sort works. We've already answered the inputs and outputs, exactly the same thing as we did for merge sort. Algorithms typically have performance. You can implement algorithms in different ways that have different levels of performance, but when we define an algorithm, we usually like to think about implementing it as efficiently as possible. So given that we're following the steps that insertion sort defines, how could we analyze the performance of that algorithm? Time complexity? Break that down for me a little bit. What does time complexity mean in more detail?
So, like in a worst case scenario,
Yep.
this is how long it would take for the algorithm to produce the correct output.
Based on what is the big variable that we're using for this?
Worst case scenario, I think, or well.
Worst case, based on? Yeah, the size of the list. Yeah. A list of 1,000,000 elements will take longer to sort than a list of 1,000 elements, which will take longer to sort than a list of 10 elements, just by the nature of there are more elements to sort. But how much longer is it going to take? That's what we need some asymptotic notation for. Tells us how the complexity grows with respect to the input. Is it linear growth? Is it quadratic growth? Is it logarithmic growth? How can we define how long an algorithm takes to run proportionally to the size of the input? So, of course, all implementations of insertion sort are not equivalent. Variables that we might choose to take into consideration here are which computer is this running on? If we hone in on a particular computer, we'll call it this laptop. how long will a particular implementation take to run on a particular computer with respect to the size of the input? Any guesses on how long it would take on another computer? Why do we usually not care about which computer it's being run on when we talk about computational complexity? Yeah, the steps don't change. So just because we're running it on a vastly slower computer doesn't mean the steps are meaningfully different. We're trying to analyze the algorithm. We're not trying to analyze the hardware that it's running on. So usually we abstract from the hardware and focus just on the sequence of instructions. How about if it were written in a different programming language? So instead of writing insertion sort in Java, if we wrote it in C++, we wrote it in Python.
Well, the code writing might be different, but the steps would probably remain much the same.
Yeah. Yeah, programming languages are an abstraction of logic.
Correct.
So if we can just find ways to state the logic, then it can be interpreted for a given programming language. We'll come back to this in a lot more detail tomorrow. We didn't have a ton of time.
Wow.
Yeah, class goes fast.
Yeah, it does.
15-minute class goes fast. But feel free to swing by my office. I play lots of Magic the Gathering. I have lots of Magic the Gathering cards to be played in my office. People typically aren't as busy on the first week. Feel free to stop by, say hi, introduce yourself, and possibly play some Magic. We have our reigning draft champion sitting right here. Come challenge him.
Wait, I'm sorry. I'm sorry, it's you or him? Oh,
It is.
right. I have no.